All right, hello class, and welcome to the Atwood's lab, or I could say AKA elevator, AKA crane, AKA just about anything with a counterbalance to help lift something else up. So what do we have? We have the same setup as we had before with the Pasco interface and the laptop. However, this time we have one slightly different piece. We have this photo gate up here, and we have this pulley. And so just make sure that the photo gate is nice and level, so that the pulley is nice and level. And we have the two masses hanging from this across this pulley. So what we're going to do is we're going to measure this thing in two different variations. We're going to measure one variation where the total mass of the system remains the same. We're just going to take some off here and put it up here and do consecutive runs or consecutive measurements, right? So each time we'll take a little bit off, put it over here, take a little bit off, put it over there, and we'll watch what happens. And we'll see how it affects the force, how it affects the acceleration, so on and so forth, right? We'll see what happens actually as we go. The second version we're going to do is we're going to have this offset of mass that we have now, but you're going to just add like the same amount of mass to both sides. And this is what we call keeping a constant force. And so as you keep doing that, you'll keep adding to both sides, and we'll see how that affects the acceleration and the force and all the other pieces of it as well. So let's go ahead and get everything set up. So we've already got the sensor plugged into the interface, so let's go ahead and start the capstone. We'll go over the setup a little bit more in class, but for the purpose of the video, I just want you to see what's happening. And so we open the capstone. You see it was trying to detect what's going on, so let's go ahead and open the interface. And let's click on channel 1. And on channel 1, we'll see right there, the third one down is photo gate with pulley. So we'll click that, and now it'll connect to the photo gate. And let's go to the photo gate. And here we only need to concentrate on a couple of things. We need to make sure that the spoke arc length is 0.015 meters, and we also need to check that the spoke angle is 36 degrees. As long as those two things are there, we're good to go with measurement parameters. However, we also need to make sure that linear speed is checked up here, so that becomes one of our available measurements that we can do. All right, so that being said, let's go ahead. Close that down. We need to just open one graph for this. So I'll just double click that, the graph icon up here in the top right hand corner. And we'll select measurements. Again, just like last time, it's open for interpretation at the moment. And we're going to take linear speed. Now linear speed, it'll automatically choose time on the x-axis, which is good because that's what we want to verify, the change in speed over some amount of time. So let's go ahead and look at our other pieces. So everything is now set up. Our system is set up. Again, we have the record button down here in the bottom left. It should be in continuous mode so that we record data as it goes. We don't have to worry about hertz and all that kind of stuff this time, so everything just stays the same. So all we'll have to do now is do our measurement. So let's go ahead. We'll pull this down. Make sure it's not wobbling around. So we'll pull that down, and we'll press record, and then we'll wait about a second, and then we'll let go. So, all right. So now we've done that. You can see it's recorded. I'm going to go ahead up here to the top right-hand corner of the graph, and I'm going to click that so it'll enlarge the graph to the actual recorded area. And this is the part that we're really concerned with. This is where the velocity was going up as it was falling down. Then it hit the bottom and it started doing all kinds of other craziness. So let's go ahead and highlight this area here. To capture that one point and to capture that bottom point, I'm going to go ahead and just grab and drag on the thing so now we can see the line nicely. So just like last time, we're going to do a linear trend line. And so I'm just going to click up here and do linear. And I'm going to bring that down. So now we have the information about that line. So the slope represents what? That's the velocity as it changes, or versus time. So that's velocity over time, which would be meters per second, which is meters per second squared, which would mean it's what? I'll leave that up to you. Okay, so going with that, that's the first run. Now, like I said, the next run we would just take 5 off of there and put it up here, and we would do it again, and 5 off of there and put it up here and do it again, so on and so forth until we fill out the chart. Now, the second chart is a little bit different in that we're going to add the same amount of mass to both sides. So now the total mass of the system is increasing, but it's increasing on both sides by the same amount. So I'm going to put 20 down here, and I'm going to put 20 up here. And so when you actually do the lab, all those will be spelled out for you to change accordingly. But for this demonstration, I think this will work fine. So the cool thing about this graph is I don't have to really do anything with this. I can just press record again and record a second run. It will save the first run automatically. And so let's go ahead and just do this again. Make sure they're not going to hit each other on the way up. All right, so I'm going to press record, wait about a second, and then release. All right, there we go. So I'll stop that. So now we can see that first initial line again. Of course, that trend line is still there because I didn't change any of the parameters. Let's go ahead and just highlight the area that we're interested in. And that will actually, that trend line will just be for that part that's highlighted. Okay, so just by adding some more mass to both sides, we can see that it's changing the acceleration just a little bit. Oh, I gave the cat out of the bag, didn't I? Anyway, so if you want to see the other run, you come up here to the data acquisition symbol and just click on run 1. And there's run 1, and you can see that the slope of that one was 0.872. And if you go back and look at the other one, you can see run 2 is 0.638. So we can see that it changes with the function of adding weight to it. We can see it changes as a function of moving weight from one to the other. And so with that, you should be able to gather all your data, fill out your chart, and answer all the post-lab questions. And like I said, we'll go through this a little bit more in class before we start, but that's the nuts and bolts of it. So I will see you in class.